Hey, welcome to a new episode of SDV Coffee Talk. Today we will talk about why ADAS is the next frontier or not. I mean, Florian has a different opinion on that. Just a small disclaimer from my side. Everything what I say here is my own opinion and has nothing to do with my employer. Let's start, I would say, with a short introduction of our speakers. Benjamin?
Yeah, thank you, Fatih, for inviting me. So I'm Benjamin Lippelt from ETAS, and yeah, I'm a software guy by heart. I think I started coding when I was 12 years old or something like that. And I was always passionate about things like Linux and open source and Mozilla and all these things. And I started my career in rail automation, so which was my first deep dive into functional safety up to Zeal 4, and even came a bit in an assessor for that. And later at Bosch and ETAS, I basically lived through the whole entire automotive software. So I was doing infotainment, I did cloud services, ADAS up to level 3, and now I'm working as a product manager at ETAS for SDV, doing products based on Cuxa, S-Core, Covida things, and others as well.
Okay, cool. Philipp?
Yep. So, well, I'm the second ETAS guy today, or this evening. I put a little more underneath for the tagging. I'm also within the Linux Foundation ELISA project to enable Linux and safety application. I'm in Eclipse S-Core committer and mainly look into the process side. From the past, I'm a strong open source enthusiast, and it took me a long time also to understand what SDV actually is about, and I don't know if I ever really made it through, so that I really know what it will be at the end. It's a good time to discuss this again. And yeah, I try to tackle things from various perspectives. I've been line manager, project manager, team lead, hardware developer, software developer, business development manager, open source community guy, process person. So I basically every 2 to 3 years I get bored about the thing, and then I just move on to the next challenge. This sad thing most interesting is that I'm participating in the ELISA project since 2019, so I think that's one of my longest endeavors in a single topic. Right.
What is your role there? Are you a contributor?
I'm the technical steering committee chair.
Okay.
So I'm leading the different work groups since 3 years now, but it's more like the organizational and structuring element because the experts are in the group. So I'm not the expert of everything. They are in their work groups.
Okay, cool. And Florian,
yes, I've been promoted to regular co-host. Thank you. Right, so very short, and in the automotive industry for 20 years, been Siemens Video, Siemens Continental, Tesla, NIO, and recently consulting companies about everything software-defined vehicle. And if I may lay the floor here, why I said ADAS is not the next frontier, but it's actually a commodity. It's about the terminology, right? ADAS, a driver's assistance system, right? So level 2 and level 2++, and so on, is not tomorrow or the next frontier. This is like, it's already said and done, right? So I heard that in China, for example, you can buy an ADAS system for $50 and put it in your car at scale.
Really?
Right? Yes.
Really?
Yes.
Oh, wow. Okay.
Because it's off the shelf, it's soft. We're talking about L2. We're not talking about anything above. So when we are talking about autonomous vehicle architectures and so on, then obviously we have a completely different talk. And I think this is mostly what we want to talk about here, not about driver's assistance systems. And it doesn't matter how many A's for advanced we put in front of it, but at one point, we're talking about how the SDV architecture can actually support driverless applications or autonomous vehicles. That's what I meant when I said it's not the next frontier. It's about ADAS.
Okay. Probably we can just start with a short, short discussion about infotainment and ADAS. I mean, these are two domains which are very, very dominant in automotive. I mean, you have the infotainment guys and you have the ADAS guys, and these work usually independent. And exactly. I think in the era of SDVs, I think there are a lot of things which are common and should be also treated commonly together. What is your take on that? I mean,
I think that's the point. So we have both are dominant, or infotainment was more or less HPC since, let's say, almost ever. And we do a lot of what we tell today SDV is done in infotainment for quite years. Yeah, we have, I think, Linux in infotainment since almost over 10 years, when the first was GM with 2015, I think. And now ADAS comes, but both is clearly separated right now in two boxes. You have one infotainment box and you have one ADAS box. And if you want to make real SDV, you need to put them together in one box and have a common foundation beyond that to run both. That would be what I would call software defined. And if you look on infotainment, you see frequent updates. Now we have this in many cars. But on ADAS, do we have 6 weeks update cycles on ADAS systems already? Maybe in China, but maybe not in all of the solutions. And that's the point where I say that might be the next frontier, because infotainment is somewhat kind of easy because it has no safety load. But in ADAS, we have safety load. In ADAS, we need to control mechatronic processes and stuff like that. And this is way more harder to do because we cannot make any deals with safety. Safety goals have to be kept, and this is no doubt about it. And usually when we do safety, we do all the things what we would like to do in SDV, we do not do, right? We just do not change things. We try to restrict as much as we can. We don't use lots of libraries and new frameworks and stuff. We just use technology that's quite proven, and we do not make updates and all the things. Yeah, and this is actually the deal we need to do, and the problem we need to solve in future. How do we bring those two things together? And this is a thing where, I mean, that might be the next frontier, the next proving point. Can SDV really be successful with all these conditions? Yeah.
Okay.
Yes. Element on this is also, if you go with, like Benjamin said, the HPC part, and in the past, the biggest compute part in the car was the infotainment, and this is changing also in the direction of autonomous driving, right? And therefore infotainment is just a part, but we are also now able to do so. Why have we generated all these little boxes? Because, I mean, we could have put also the boxes together in the bigger box, but this would mean like having different CPUs in there. They have been spread because you cannot just get the computation performance, and that the computation performance increased. That's what you can already see was from the infotainment space, actually, because there is L-shaped architectures where you put safety workloads and a hypervisor underneath, and then have an Android and a Linux system next to it, plus another cell for example, instrument cluster. You render your rear view camera, which is attached to the infotainment, also into the instrument cluster, which holds a safety workload. So therefore you see that this actually migrates, and this enabled us in doing these kind of things. And then also at some time, so that's where mixed criticality first comes up. And then you can now say, okay, I have here compute platform, I have a perception part, and that somewhere in there should be enough space to also host my infotainment workload, either as a VM, as a container, or whatever, right? And that's where it is. And the important thing here, I guess, is the people who built these infotainment systems, they bring a strong background in system performance, stability. It's not about safety there. But I remember that we were not supposed to have any kind of black screen reset or anything, and we had to start up in 2 seconds, and all this was a Linux system, and it worked. So like, I haven't experienced the reset. I've experienced one reset in 70,000 kilometers from my infotainment system. And it's just consumer electronics, right? No safety or anything, but it just runs stable. And it's a device from 2010, 15 years runtime, no issues, stable, Bluetooth connection works, no resets, and it's just like standard components. It's not even safety critical.
Okay.
So a couple of thoughts. First, we have already 2026, so it's 16 years.
Oh yeah.
Second, Tesla put Linux into the cars in 2012 already. Not automotive grade though. But so there's a variety of things, right? So you have like high-level applications, driver-facing, and you have low-level software applications, embedded applications. This is where we traditionally drew the line, right? So you have like everything that has a screen doesn't have anything to do with my safety because it only entertains me. But and everything that is like really safety critical runs in embedded systems, and it's like molded in there and it's locked in. But now we are seeing how those things are merging together, right? So yeah, rear view camera is one example. But also we get more and more controls into the screen, how we can actually change the driving behavior of our car. And at one point when you move to L4, you actually use the screen as a primary interface. There's no steering wheel, no pedals and so on. And then you suddenly talk about a completely different topic. And that's what we exactly what we're talking about here now, right now.
I mean, I have just one question. I mean, recently some OEMs just announced, I read in the news that they give up this L3 plus self-driving things.
I don't think L3 ever had pluses on it. The L2 had pluses to it.
Or L3, L4, whatever. I mean, how they are called. But many OEMs told, okay, they will not develop this anymore. I think this is some strategic change in the business. What do you think about that, actually?
Well, fun fact, I heard that it comes back. So you're right.
Oh, really?
It is actually, I think Mercedes-Benz was one of the first bigger companies bringing a L3 certified system to the market. My personal belief is they did it because they want to be the first. That's the core thing. Why they invested so much money, and BMW has to follow up with them. They did also a good system. So those two they brought it to Germany, I think, and to some states of the US, and now in China it comes up. But nevertheless, the systems actually were made for traffic jams on highways. So they were up to 60 kilometers per hour because the regulation from UNECE did not allow more. That was working fine. I was driving in those cars. It was really cool, but it was not an everyday use case thing. And now they extended it a little bit, but it came clear that the faster you go, the more computation power you need, and it's getting harder and harder. And that's why I think they say, okay, let's try level 4 and all with a completely new architecture, because the architectures are still distributed. And now we come with new generations of a new power of the HPCs and all the things. So now it's actually in the 30s, I think, the time of the actual automated driving systems.
So there's also this big regulatory problem with L3. L2 is drivers in charge, L4 is cars in charge, and L3 there is no clear definition where this border is. Somebody says it's 30 seconds, somebody says it's 3 seconds, somebody says it's reasonable, whatever it is, but there's no real clear defined value that is applied to everybody.
Yeah, and I believe the L3 story could be a lot about the price. Because when you go from level 2 to level 3, you're in the first time where, as you say, Florian, it's no longer fail safe, it goes into fail operational. So you detect a failure case and you need to operate in the case of failure, and you cannot simply switch off the system or give the driver 500 milliseconds, because the driver always has the hand at the steering wheel and the feet at the pedals, because they're just waiting for taking over, right? This is no longer like you wait for braking and steering all the time when you drive with level 2++, which of course nobody does, but that's the idea behind. And in level 3, this would disappear, and suddenly you put more effort on your architectures. And I had these discussions because you see the L2 systems which run Linux today, and then they said, but you cannot make level 3 with fail operational. So how can you not make level 3? You can go, I heard about level 4, level 5 systems which run Linux. And they're like, well, that's a different story. So why is it a different story? Yeah, you work with redundancy, but we cannot afford this redundant system architecture in level 3 for the market segment which we are targeting for level 3. So it's not a technology issue, it's basically a commercial consideration.
Okay.
But I mean, taking it to the extreme, you can say, like, if I develop a level 5 car or a level 5 system, I can basically use it for level 4, level 3, level 2, level 1. You would not do it. Doesn't make sense. It's commercially completely not reasonable, but you could argue like this. And then the need for level 4, level 5, commercial vehicle parts and so are much higher rise and a much better way to go for than trying to squeeze and optimize all these level 3 things. And then maybe over time, we get just the price decreases so much that you may also entry class level 3 instead of level 4. I don't know. This is just, there's something to consider.
Yeah, but exactly. So the L3 has to satisfy both bars, right? It has to be the driver car and it has to be the driverless car, and that both in a price point where a driver would still be willing to and can afford it.
Yeah.
Okay.
And then it gets really tricky on the software architecture as well, on the system architecture, how to get a good argumentation. And when you're in higher levels, you can do a much better decoupling. And then it's really the question, and we need to ask this. We always talk about mixed criticality in automotive, but aerospace does not bring mixed criticality. They separate these things, and this helps them a lot. But of course, a plane is far more expensive than
yeah, but a different thought on here is as well. As soon as you go L4, you can take all this disturbing like driver controls out of the vehicle, because I think one of the things Waymo developers currently have the biggest headache is for what if somebody's jumping in the driver's seat and smashes the brakes or pulls on the steering wheel, right? Because the car was designed as an L2 platform and they added the L4 on top of it. So once you remove that, so we have here in Vegas, we have Zoox, right? There's no anything. There's just an emergency, please stop now button because I'm not feeling well. And that makes the decisions, the development and the safety design much simpler, because you take out like SOTIF cases, like people doing something bad either on purpose or because they do it by mistake. And that makes the development much easier for L4.
And then it may be important to also get connected services so that you get, when, let's say you enter into the car and you may have a certain preference on how things should look like in that car. So even if it's fully driverless and you don't have no steering anywhere because you don't have the control, but you want to have it feel a bit more like your way of driving. Of course, there are the normal boundaries, but let's say for the one person, a way of driving is super defensive, and for another person, the same way of driving can be offensive. And I guess that's where we come in, and we put this like SDV, next frontier software, and this is like the hyper personalization, being able to load profiles and to change the profile with the driver to say like, here's my configuration, I just enter and get things applied. This is then a different story, because suddenly you're driving. Autonomous driving and functional safety systems need to react on certain configurations. You need to make sure that these cannot be hacked, that they are only operating in boundaries and so on. But then you get also more software-defined parts and really can influence and enhance the functionality over time, right?
So quick follow-up question. Do you think this is maybe more like a bridge kind of thing? Because right now we are actively driving, so I want to take my driving style into the autonomous, but 1 or 2 generations down, people who don't, have a driving style, maybe they don't care for that at all.
I think that's the valid point, because a lot of people do not even take the younger generation and see the number of people there who have a driving license when they turn 18, and take previous generation and see how many more have driving license and how many more are relying on public transportation, on Uber and other parts, do not want to own an own car anymore. And if you're not making a choice on a car, I know people who bought Audi, BMW or Mercedes based just on the way how the suspension is and how the driving feeling is, right? And then you want it. I don't hear this.
That's what the commercials tell you in the TV, right? It's the ultimate driving machine.
And then with the electric,
it's kind of different. Some people don't care on that. So I think also in the US or in China, people don't care if there is a driving wheel or something in the car. But in Germany, I think you will not sell one car without equipped with a driving wheel in the next 10, 15 years. And that makes things more different.
I think it depends where. If you're like getting from the airport in Munich to the city, I think not many people would like to drive that themselves. If you're driving up the St. Bernard Pass in the Alps, I'm sure people would enjoy that. So it's maybe not the same vehicle at that point.
And it's also about what you say, like, nobody will buy a car without a steering wheel. I agree on this, but it doesn't mean that nobody wants to ride in a car which has no steering wheel. And that's a different market, and it's a different attitude. I'm sure that the people buy a car, own a car also for or also for convenience. This will be also the number of people who say like, yeah, for the convenience function, I would like to have my personal robo-taxi. These are maybe also people which owned a driver in the past, because there were already people who bought cars with steering wheels to hire a person which drives the car with the steering wheel so that they don't have to ride anymore.
This is the ADAS system. This is the ADAS system, I mean,
this is the human. No, it's an autonomous system. It's definitely L4.
definitely. But I think also acceptance in the society is very important. This technology, probably the big OEMs told, okay, we don't, develop any more L3 or higher because they didn't get the acceptance. I don't know. I mean, this is just an assumption. I don't know if this is true, but this is at least what I read between the lines in the news. I mean,
I heard a very striking argument this year. I think one of those which stick most to my brain. If you take driver accidents, like not totally fatal, but where people get injured. If this is, let's assume you have one brand, and in this brand, 1,000 people over a year have accidents on this brand. And a bunch of them will die, because that's just normal, right? People die in the traffic. On that brand, it's always a driver fault. Let's assume it's 100 people. 100 people die over a year, or 500, whatever, in a year. Die, it's always the driver's fault. If 500 cars of a brand will kill a person, then it will not be acceptable. What is the acceptable number? Is it 500, 100, 10, 5? If we go for like 5, and it's about ethics, right? But if we would say like 5 people is the acceptable amount, and normally 500 will die, it means your car, your autonomous driving, need to be 100 times better than the human driver.
I heard OEMs saying they are proud on that nobody died because of a malfunction of the ADAS system. And that's exactly true. So if you look on reports and newspapers about accidents, you never read, okay, somebody died in a car and it was whatever kind of OEM. Nobody will take care on that. In the moment where the car takes over responsibility, this is a totally different topic. And that's why it's so important.
Also legally, it's different.
Of course.
I mean, it's a legal issue.
That's the big problem with L3, because there's not a clear line between who is who.
And there you could also make... Benjamin.
That makes it more challenging, because that's right what you said, Philipp. Yeah, the system needs to be way more better and way more fail-safe than a human driver would be. Yeah, and that's actually the big challenge. And even the different use cases we already discussed, it makes it not easier for the OEMs, because they need to address the different needs, and the system, the architecture, needs also to address the different needs. Or we need different architectures with different systems, which increase cost of development. And this really, getting more fragmented use cases and the fragmented behavior and habits of the people does make not life easier for architects and system designers and stuff like that.
Yeah, and then we talk about software defined, and just bringing up the cost element of the systems. And we said this like in the teaser of it, that maybe ADAS becomes commodity, that most of the software parts become commodity. And that's the point where we need to see, like, how do we bring in things that we are portable, that we can enable a certain set of competition in the field of commodity. And I guess this is also what brings in, for example, now the people start considering Linux for safety critical parts, where they say, okay, then I have a choice of I buy something from let's say Electrobit, CodeThink, Red Hat, NVIDIA, WinRiver, Linetronics, ETAS, Bosch, whatever. Right? You have the choice, and you start opening this, and you can come and count on standard interfaces. They ask for POSIX so that they become compatible, and then also say, like, here is something I differentiate over some part of algorithm smoothiness about the user experience which I deliver, not as an ADAS function, because the ADAS function is expected to work. It's expected that you feel good in the car, whatever, that you can deliver comfort or whatever. It's user experience later on, and this comes with the SDV part. And in order to reduce cost, you need to make mass production, mass cars, mass APIs, and this is typically open standards. specific layers on which you can then start a competition and choose your distributor of choice, right? And I think this is also some part where, for example, Eclipse S-Core comes in, right? Where
probably, I mean, we discussed about the strategic and also from society perspective, but I would like to shift this a little bit in this direction you already started, Philipp. Okay, the failure case. I mean, systems can fail, and in ADAS, it's fatal. People can die. And we have this safety issue there, actually. And I hear very contradicting discussions, actually, about Linux in this area. Should Linux be used, or some other system like QNX or so is more, suitable?
Yeah.
I see also many initiatives where Linux is, so to say, it becomes more safety relevant. And what are the initiatives there? I mean, can you probably a little bit give an overview there about ELISA? I mean, you have already also a T-shirt from ELISA project, probably.
Yeah, I mean, in principle, you can see there are various service providers which offer a Linux-based solution, and I just say Linux-based solution because people start arguing what is the right architecture of it. And what you can see, there is some foundation which just keeps Linux as a quality managed element, and which means like no safety allocated directly to the Linux kernel. You will work with some patches and some parts, but you do still have like monitoring. And then are those which say, instead of putting the monitoring next to it and have some interprocessor communication, end-to-end protection, watchdogging, and so on, you put it underneath with a hypervisor. So you give much more responsibility to the hypervisor, but you get higher control. That's what the argumentation path is. And then, of course, there is a third path where say, well, we remove a lot of these monitoring things beside, we throw away the hypervisor, we concentrate on this full-blown Linux, maybe with containerization also still, because you have this for like customers. What they all have in common is typically one architecture, and this way typically works up to the level 2 plus ADAS functionality. Why? Because there is no guarantee, that 100% guarantee that your scheduling in a Linux scheduler will always work, that there is not certain memory corruption. I will not talk about hardware issues like that the memory could not be correct, because this is something which would also be there for QNX, right? And here comes then the trick with the level 4 part. You can also go for redundancy. So you could buy, for example, two Linux providers. You can combine an x86 with an ARM system. You get for diversity. And that's then where you can have benefits of independent development. And you could, it's always like, I go for this Linux, I go for the other Linux, and we discuss a lot about these things in the LISA project, like what is the best architecture, how to make use or not. But in the end, they are all valid architecture if you're aware of your system design, if you know how the system should operate, what are your use cases. And the first thing is always, that the people come and say, you cannot use Linux in safety critical application. And I say, well, we can. That's it, right? And then,
why this topic is so emotional? I mean, if a discussion starts, people get very emotional on that. I don't know why.
Yeah, I think it's. I assume it's because it's a shift, and it's like I can understand it because on the one hand you get far more control because you suddenly see source code and see everything, but you also have hard times in applying an ISO 26262. So we have the traditional standard, and the standard is the thing which tells you where you look at. The standard was prepared for microcontroller basis, and it's still like, let's say 1,000 lines of code, 10,000 lines of code. What do you do? It's not even thought that you configure software. Basically, you have 100 lines, 100% code coverage, argumentation, and other parts. So you make it really condensed, and it's typically relying on microkernel architecture. And well, Linux kernel is a monolith. It's not a microkernel. And actually, this discussion was on the Mimics mailing list where Tannenbaum told Linus Torvalds,
never worked.
Read it somewhere, right? Monoliths are death, the future are microkernels. And you see this there, and I see this repeating. We're losing this is now happening for Zephyr. Zephyr from Linux Foundation gets so much drive currently, so many people jumping on it. And I actually also hear those which say, that's the monolith. That's not good. There's so much peripherals in there. It's not made for automotive. And so you hear exactly the story also there for applications. But you see also that this basically repeats what Linux has done 20 years back. So let's go maybe 10 years further. But this was always there. So Linux is there. And of course, a bunch of people are just seeing there's something coming up. I think the more discussion this brings, the more you may be on something. Right, because you put someone in the corner and the people start punching because they feel like they're losing their space. So this can start, and I think this is the emotional story. And of course, you really need to know what you're doing there. So if you do not bring a safety background, if you do not bring a Linux background, don't go there.
Yeah.
Right? You should know Linux and you should know ADAS, and that's where the companies which coming from infotainment world in the past, which have done infotainment devices, which have worked in automotive with ADAS, these are the companies which are good when they manage to bring the teams together to discuss this. So then you can go forward. But that's the part, and we need a lot of education. So people need to get trained, and they can get trained on what are potential risks with Linux, and there are risks with Linux. Just from the commercial RTOS side, if we take this, so I would put it wider. If you come with a commercial RTOS, which is really just a microkernel, everything needs to develop around it. So you will take, and I make this as a security example. Let's talk about some cryptography library. Will you really develop everything from scratch, or will you trust a library which is already existing? Well, you go, of course, for the microkernel approach. So you just buy the cryptography kernel, mini kernel part, which does hashing, and you build all the things around it. Now, you wouldn't do, because you know that you say, like, okay, here's something which is used in production many, many times. So I trust in this. I have evidence. I have the CVE tracking. I see the updates, and I have all this. And we need to show much better the evidence also for safety. Where can we provide evidence and also transparently show where are gaps, where are the CVEs for safety in the environment to make sure that we're not ending up with single person writing safety the first time because they're saying that my microkernel architecture is far more safe than the other one, and therefore I write every driver on my own. This will most likely not work.
I have one other point on why people get so emotional. So first, I think we have many emotional debates in software, so that's some kind of. And the other thing is, I think that people being in charge for safety and for security and being architects, they show incredible ownership and responsibility for the systems they are responsible for, and they have a base which pretty works well, right? So it's pretty good what works, and that is established, and that's quite safe. And if we now say, let's change everything, then we need to rethink everything. And when I was doing a level 3 system, the first discussions we had with the safety people they always said, okay, let's have a look how we did it the last time. And we always said, hey guys, there is no last time. It's the first time we do this. There is no blueprint. The safety goals are the same, but we need to think how we achieve the goals. The way how we achieve the goals need to be rediscussed. And this is incredibly challenging. The time frames and schedules are always really challenging, and this brings a lot of pressure on those peoples. And I think one core reason are the humans and the people working. They show ownership. They are responsible for that. They want to make a really great product or to make it safe. And now come some freaky Linux guys and say, oh, use Linux, it's cool, right? And this is, I think, where the discussions go. And then also we have evangelists. They say there's only one solution. For example, that's Linux, or there's something else. And they are not willing to move away from their discussion point. And if you want to change things, everyone needs to move away from his or her point, and then we find a new solution. You cannot make steps on a new path if you stand on your point.
Okay, but is actually the kernel, I mean, how it is at the moment in Linux, that's monolithic kernel, is this a problem, the root cause of all mistrust? I mean, or Are there other aspects?
It's a strong part of it, just the complexity and size of it still, and and you cannot have guaranteed real-time scheduling even with pre and RT configuration. You're not have 100% guarantee on that things are, but this is also due to the amount of features they're using, how much they make use, how much clever ideas came from the server side and so on. So it makes it harder to predict. So there are enough people which say the Linux kernel is not deterministic. It has to be deterministic to a certain extent. It's just from the complexity, it looks like only pseudo non-deterministic. And therefore, it's really like this, and you need to find a good argument for freedom from interference, how you isolate things, and then how to really show that the risk is low enough. But we see that this is just evolving year over year, and the control gets better. And this is also due to the increasing amount of hardware features, and especially from the security IP blocks, which getting in these security IP blocks help us to bring in functionality into the Linux kernel, make use of it, which makes it harder and harder for something to have an interference also, right? So we are really improving on this a lot.
How is it actually? I mean, this is now, I think, a little bit delicate question. I mean, nowadays, everywhere are AI agents producing code and so on. And I read a couple of days before that Linus was just complaining about the amount of code which is produced for the kernel automatically through agents. And what do you think? Will this make the kernel better? Or
I would say this is a current hiccup. So this is now because people start playing around and doing nonsense. I don't know if it's a good comparison or not, but imagine you have the first 3D printers and how many nonsense the people have just printed. And the first half year you print all the rubbish you can imagine. And then after half a year you start printing spare parts, geeks things which improve your life or whatever. Your desktop holders, which is still rubbish. No, this is there. But from the other perspective, there was also a flood of wrong vulnerabilities issued for security things. I think it was with curl, but I'm not exactly sure. But I read about where it said like originally we were flooded with all these vulnerabilities, and this at some point in time we ignored them, and it ended. And now the people who did the work before, who know about security, they start making use of AI tools because they know how to do it, and they get much better vulnerability reports and on a higher quality, higher frequency than they have ever experienced before. And you can definitely see that it's because of the AI part in there. And updating documentation, understanding functionality, bringing things in, this can actually change something. And we have now from 9th to 11th, we have an ELISA workshop in London, and we actually have like a 3 safety session on the second day, Wednesday morning, where we spend a lot of time on like how to create requirements, how to do verification parts, where to utilize AI. And it's also driven by NVIDIA, because NVIDIA just brings the power to do so much things, because they can just they can throw tokens around as they want. They are the owner of it. So they show what is possible, and there is a lot of things possible. And I also heard from safety assessors, which says like, okay, this is a promising path in understanding code and improving code and finding errors, because the size of the system is so huge that by independent review you cannot manage it. So
what do you think? What do you think on long term? I mean, you guys, I ask all you. What do you think? Will AI make such system like Linux kernel or other critical systems which are, used everywhere? Actually, I mean, Linux is not only in the car. I mean, actually the whole internet runs on Linux. I mean, all cloud and everything. Will it make it better in perspective of safety, security, or will it be introduce more vulnerabilities in the code? I mean, what do you think? What is your gut feeling? I mean, it's just.
I'd like to insert the question here, because we just used the word Linux for everything, right? So, but where do you differ? I mean, it's obviously not the Linux that is running your cloud is very unlikely the Linux that is running your ADAS system, right? So maybe you guys can just like draw a line there, or like create some boxes and say like this is this, just because we all label it after that one guy.
At the end of the day, I think AI tools will help doing things better, but you need to use them in a smart way. As it's not a silver bullet saying we just make some AI on something and then everything is fine. Yeah, you can. I think there are great areas of appliance where we can use that. It helps a lot because it sees a lot of things. It can even work in complex situation and can put your eyes on things where you may not have been looking for. We've seen great AI tools for comparing requirements with the code, so we can make the traceability help there, but it's not a silver bullet. At the end of the day, humans need to have a look on that, and humans need to be in charge and being responsible for making the final decisions. That's as always, and AI is more or less just a great tech thing. When computers were new, we also thought that they will control everything. We know where we stand today, but it's a tool. It brings in great productivity, but at the end of the day, humans need to make the final decision.
Okay. Mm.
I would also say, like, well, we could say, like, what do you think, will the steam engine make every person in the factory obsolete? It was not like this, and this is, the AI is a tool thing, but it has much more potential. And I wouldn't say, like, I don't know where in 10 years AI will go. If we have like the one and only AI, maybe the AI will produce 1 million paper clips and destroy the whole universe because of all the paper clips, right? This is the one scenery of it, because it's just getting, and then the Linux is just another factor, so it will be, but it's, at the end, it's really like how you make use of it, and it has potential to destroy, but there will be the potential also to defense, and we see that it can help finding vulnerabilities today already, and it will also work on this for safety, and we just need to come over this first wave, because a fool with a tool remains a fool, right? And
Exactly.
that's where it is, but it helps us. So it can. You need to understand what you're doing, and I think that's what Benjamin also said. You need to know what you're doing, and then you use it properly, and then it will save you a lot of time. And all these improvements and all these things we had in the past, every improvement just made us saving time to spend more time on becoming more effective, more productive, and so on. So we will have a phase of innovation. We will be faster. That's my feeling of it, but it will not make people obsolete or so, and it will not be the standalone thing to increase the quality, but it will increase quality.
Okay. Probably we can just talk briefly about actually in the S-Core's role in this ecosystem. I mean, last year, I think, or 2 years ago, I can't remember exactly when S-Core was released. There was a lot of hype around this. But what do you think? What will S-Core, or what kind of value brings S-Core to the whole discussion as a project?
Yeah, S-Core. So we are currently on release 0.7, and S-Core actually is a kind of it's a middleware. It's not an operating system. It runs both on Linux and QNX. That's important to understand, and it's important for us in S-Core that we can run on different operating systems. Yeah, that's important. It runs on SoCs. It's not something for the microcontroller area, and the idea is that until the past, or that some years ago, or now, all the OEMs together, the partners, were developing their stacks alone. And there's a lot of commodity functionality which has been developed, and logging frameworks, communication layers, diagnostics, and all the things. And there's no real differentiation. And the idea is, hey guys, let's do something together, and we start at a greenfield. In one term that we say, the first thing we do is not just writing software. The first thing we do, we understand we are in the automotive industry. We write down the process. So we have a clear process. That was the very first thing the team developed. And it's already a great achievement that we now have some clarity on how the process looks like, and that there's some clarity on what is the actual code coverage percentage. And everyone is working with S-Core, it applies to that. That's the first thing. And then we say, okay, now we write software, and of course, S-Core reuses a lot of software which is already existing. It's not like that we start brand new. We just take components which we have already and bring them together to something which is open source and which is less standardized than adaptive AUTOSAR was. So, but a lot of things are coming from the adaptive AUTOSAR world, like the communication layer we have right now. MWCOM is pretty much close to adaptive AUTOSAR, but it's not that spec driven. It's code first approach. And again, it is the common things together. We use them together, and we different partners bring it in. They bring something in and they get more out. And that's the actual idea behind Eclipse. And the other thing, it's under the Eclipse Foundation, so it's not a kind of single vendor governance, but it's a really open source project where no one big company has the ownership. It's the Eclipse Foundation as the framework, and a lot of companies working in there. Yeah.
And there's a lot of just a quick thought. There's a lot of discussion in industry what differentiates you actually from the competition, right? And at one point they really figure out, okay, it's not that software that is running my drivers and stuff like this. It is the user facing, the user experience part of the software. So that is what brings you differentiation and what brings you brand image. But what kind of RAM driver you're using doesn't have anything to do with your brand image.
Yeah, which is basically summing it up to like nobody will buy a car because it's running Linux or it's running QNX or it's running
Exactly.
whatever.
Exactly.
Right? It's not
Exactly.
I believe there will be not a single person who goes into the shop, and now the single person will say, yeah, that's me. I go into the shop and ask, like, can I get the Linux car under these cars? And then the seller will say, yes, of course, we have different Linux flavors here. Which is your favorite Linux flavor? I want to have this one with a nice sticker. No, that will not happen, right?
So you're going down the road as like what I do with my laptop, right? I buy it with Windows, delete everything, and I put Linux on it. So you're going to buy the car with the standard operating system and just put Linux on it later.
Yeah. But I think one thing about the S-Core part, and this may tie to the comment which was there. So you brought up the comment and says like ISO 26262
Right.
mainly expect us to know what we are using. I would say like it depends, like typing is fast. I wouldn't say what we are using, because the ISO 26262 main part is about creating something. You create a system, you are bringing a system. Of course, you consume parts in there, but still it's then about the, what's coming there, possible issues. I would call it like the acceptable risk. You calculate and you do all the measures to bring the risk to a level that it's an acceptable risk to bring this product into the field, because you will never be able to say this is 100% safe. I have resolved all issues or so, but you can just say I took all the measures, and that's like the procedures mentioned there against them. And of course, this is a methodology. It gives you recommended practices and so on. Why this is something, this is something in S-Core, which we have because it is an ISO 26262 compliant thing and we are auditing it. You shouldn't underestimate the other parts of it. So what happens is it's getting discussed, and the topics in there, these modules. So the one company brings in a module which has been used in production, which went through certification. It now, of course, need to be adopted so that it fits the S-Core methodology. You get standard interfaces, which is brilliant. Practical example, we once changed the Yocto supplier, and then with the second Yocto supplier, because everything were the same interfaces and so on, the developers were ramped up in no time, right? This gave you benefit. But that's not the point I wanted to make here, which of course is also something for S-Core, but you have competitors working on the same software, looking into the same stack. And what could be better than two competitors checking their solutions and come to the best technical solution? I mean, this supports safety, because what you lack in your company, let's say you do an FMEDA or FMEA, it has to be done by an expert, subject expert, well, subject matter expert, whatever. Expert. You know the thing. Yeah. So this is the guy. This person will be biased. Just naturally biased, because these are the person which is developing it. The one who is doing the moderation of an FMEA is also not an expert. But if you have someone who writes payslips, and we all have these implementations around, so it's not. So when we come to S-Core, there's a new component. There is pitching in the architecture around, and then we decide for the most mature solution and the best fitting thing. But the other people in S-Core still are there, and they can review and see what's happening there. So suddenly, people who were not working together, who are experts, can cross-check things. And this you cannot do in your closed environment, single development environment. It's just enables, you need to have it open, you need to have the chance, you need to have a room, a neutral governance where you can discuss this, where there is no no conflict, and you have all these things still, because this is important when competitors come together, you have all the antitrust environment and frameworks so that you can also be compliant in your development. And that's why also we see, to my perspective, a stronger move to open source, away for a bunch of previous consortia, joint venture parts, and so on, just because you really get much easier life with you have your documented minutes, you bring the things there, everything is open, everything is public, every competitor gets the chance, you can set something like state of the art, you can create new things, and this makes life just easier. Sharing information, exchange, and you typically really stick to the technical problem which you solve together. And that's a nice thing, without the boundary of paying member fees or so. Too much, but you also
could use a word on how that works in SCore, how the feature requests come. So you have a feature request, and they say, okay, we need the following feature, and this is decided by the architecture round. And then there comes proposals. Yeah, that makes they make different companies, groups can make proposals, and you have maybe 1, 2, 3, 4, 5 different proposals. They are just discussed. So you need to open source them already. So everyone can look. And I think what we saw on lifecycle management module, the architects found out there are 2 cool solutions of 4, and let's pick one component from the one proposal and the other component from the other proposal and bring them together. So you get best of all worlds. And then this comes into, and you still have all the people from the community in, and they can, what Philipp said, they can have a look on it. And this you only have in an open source environment, which is driven by a foundation, not by business decisions. It's a clear thing, and it brings in quality, and you get many great guys in from the whole world. It's really there's people from China, Korea, Germany, US, Europe, and that's such a big pool of expertise you bring in. That's why I think it's really one of the best solutions we have here.
Okay. But I mean, this is just one piece. I mean, if we go more and more in this open source, and the automotive use more and more open source, I mean, this doesn't this bring also some more how to say? I mean, how I think in automotive we have this environment where people just keep things private, I mean, and not share with other people. Now this is changing completely, and I'm not really sure if this legacy OEMs are really ready for that. I mean, because this mindset is still there.
It's not only that, right? So you have a variety of reasons for that. Contractual reasons, because they're like those 30-year contracts.
Exactly.
The mindset is like, we never did that, we will not do that. And there's also a false understanding, is like protecting my intellectual property. It's like, well, this is not really intellectual property, right? So you wrote low-level software that is clearly following a specification of the processor or chip manufacturer or whatever, right? So if somebody else is writing it, they write exactly the same code. So is that really your personal intellectual property, or is this just like labor you put in there, right? And at that point, you can treat that slightly different. But I mean, I wanted to say that earlier already. It's not an ADAS or Linux specific thing. It's an SDV specific or next generation automotive project specific thing that we all have to change a little bit where we come from to where we go, right? Mindset wise, processes, method, tools, all of the above. And it's not just one plug and play. It plays all over the SDV world, that you always have people who's like, we never did it that way, so we will not do it that way. And then you have the other group who say like, you can never do that if you want to be ASPICE compliant. And this is all not true, but it is always a great excuse for some people not to change their mindset, right?
Yeah. And I guess that's really true, that there is a lot of not direct willingness to move forward, to share, and this is what's really hard still. And I think there the
change is stressful.
Yeah. But are you guys actually in contact with OEMs regarding these projects like SCore or other ELISA or so? Are you in close collaboration with OEMs? I would like to know your perspective, how OEMs react actually on that. I mean, how open they are actually to adapt.
I think
BMW is one of the biggest committers of S-Core. Yeah, so
it's the biggest one actually. Yeah.
Yeah.
But the thing is, you need to attract certain OEMs in order to be robust on it. If there is a dominance by one OEM, this can be actually a drawback for the project, so it's better to scale. And in best case, you would also find OEMs from different industries so that you can say, here's a passenger car and here's a commercial vehicle company, because then you lower the concern about sharing intellectual property and or use cases or markets or so, right? There's always like, when I do this, then I will do that. And what about this part? Even if the people want to open, it's something which was trained to them and to the management for decades, right? So they came into this environment, how to keep market, how to gain market, how to compete. And therefore we have this, and your question was going like, are you actively talking to AMs? And for sure I will not name names, right?
No. What is your experience? What is the experience?
What I experience when I talk at environments, I see that there is a good perception on it. So I had several conference talks already on S-Core, and I see the people are coming, and it's here, it's in Asia, and we get certain feedback from US. I also, of course, see people who are on companies also which just are saying, no, that's nothing for us. And it's also not only about S-Core, it's also about other parts. So you see those which are progressing. What you can see is typically this is nothing for us is a sticking to what you've always done mentality. It's not like change, and thinking about like, okay, we are, like you say, okay, that's maybe too risky for us. That's what they say. We were not ready, and we need it now. Either we need it now for the next generation. Oh, you're not done. When will you done? Oh, I come back when you're done. Please align it to my SOP cycles. That's the one part. Or, oh, I have only money for the next acquisition, and it's really like looking forward to maybe to the over next generation, and to bring in parts of it, to have a transition path. And one strong voice which I really would like to mention is also next, like BMW was from Benjamin for the S-Core. Within the automotive grade Linux, there is Honda who is promoting the SODEV, the software-defined vehicle part. They had several presentations, and they try to build up architectures and software-defined vehicle system architecture. They have Android, Zephyr, Linux, and they try to build it on open source. They said this in the keynotes at the Linux Foundation Open Source Summit Japan, where said, we want to get more control about our stack. We want to control our stack. And I was first concerned, and it looked like, oh, we want to do everything in-house, and say, how do they want to achieve this? What is the idea? By reading between the lines, you can see like, we want to have the chance to change. We want to have the chance of influencing things, and we want to get control in the way how we create our system and not being tied into the vendor. And that's why we try to build an open ecosystem and draw this. And they are looking for a much longer time frame, as it seems. It's not that they say, and they also brought iterative parts. So we could see here is the bench, the demonstrator from, this is our system today, this is our architecture. Here is the reference sample board from the latest chipset from Renesas, that's what they had there, and say, this is how we envision future architectures. And spending a bit of this there and keeping really the product in mind, because we have also the other OEM parts which say, let's build this POC part thingy, and then it's decoupled from really the next product. And they really go evolution, say that's where we want to go. We bring in the first element there, learn from it, and then envision it for the next one. So this was how I saw this at Honda side, and how I really like the way how they're doing. So by this, greetings to Kusakabe-san in case he watched this.
But this is definitely a good topic for another episode, actually. I mean, we came to the end of the episode, only 2 minutes left. I mean, if you have anything, last words you would like to say. But I think we should definitely make another episode with this topic. I mean, the strategic path. This is really cool.
I think we could talk for hours about this without touching everything. Yeah,
we should definitely do that. Any final words you would like to share? Or
final words?
I would conclude with, at the end, it's actually not about the any kind of standard like ASPICE ISO 26262. It's also not about open source or proprietary thing. It's about the forward thinking and changing perspective from what has always worked to how can I create a competitive product with certain pricing, which is flexible enough so that I have really software defined and can change over time and take into concern the longer lead times, or longer lifetime of it. And I think that's where we need to go for. My last 5 cents on it.
Sounds good.
Okay.
Perfect.
Yeah, thank you so much for joining. I think we should definitely continue this conversation in one of the future episodes. I think there are a couple of questions still open. We didn't discuss about that. Yeah, thank you so much, and see you in the next episode. Bye.
All right. Thanks, guys.
Bye-bye.